contains irrational things. For example, integral of a function which includes x as well as some irrational things, that is 1 by n. Something for 1 by n means nth root, that one. So that like if you are having something and we have to integrate them means, how we can do means we can make a proper substitution. That substitution is, instead of this ax plus b whole power n, wherever it comes 1 by n, wherever it comes, we can apply them. That particular ax plus b whole power 1 by n is t. Okay, that gives us the substitution. This is the standard substitution. T power n is equal to ax plus b. When we take power n on both sides, we get this one, right? So this substitution we have to make. And then the second one, integral 1 by x minus k into root of x minus k whole power r into root of ax square plus bx plus c. For this types of integrals, we are supposed to substitute this x minus k is equal to one by t, like you can substitute. Okay, and then for the next one, third type of integral, we have to integrate 1 by ax square plus d into square root of cx square plus d. Then this type of integral also we should substitute x is equal to 1 by t. After that, this will come under another known form of integration. Okay, and then fourth one, in that it is of the form ax square plus bx plus c divided by dx plus e into root of fx square plus gx plus h. That is a quadratic function divided by one linear into square root of the quadratic. When this type of integral comes, here we have to substitute it like, you know, this numerator ax square plus bx plus c, that is equal to this one dx plus e is extra, right? Dx plus e into differential coefficient of d by dx of this one fx square. Here I will write, let me write. So dx plus e into a d by dx of this one fx square plus gx plus h. Okay, and then plus b into dx plus e plus c. Okay, see, these are all the things we can substitute. So whenever we see a question, it is of which form we have to understand. Based on that, we will make a substitution. So when you see a question itself, we should know. Then here, these are all the things is what? Outside also one, say this is cx square one. Outside also a quadratic factor multiplied with the square root of the quadratic things. And then here, this is entirely different, right? But I will give you an idea. You see, if you remove this dx plus e, this is nothing but what we have seen earlier, right? Kind of what we have seen earlier only, right? In that, what substitution we made, you remember? A into d by dx of the denominator plus b, like two constants we written. So just because dx plus e, one linear factor is multiplied that in front, we get this format. That is a into d by dx of the denominator only. With that, what is multiplied? That linear factor plus b into that linear factor plus c. Three constants will be there. Okay, we'll solve on examples regarding this. Shall I write these things? You note it down. Okay, we look at that illustration 1. Evaluate integral x divided by x minus 3 into root of x plus 1 into dx. Now this is of what format? This is of format 1, 2 or 3. Sorry, this is 1, this is 2. See, this of second format, is it? X minus k is equal to 1 by t, like we can substitute. But when you look at it, the format closely, linear into square root of a quadratic. Square root of a quadratic is always giving us a hope. Like we can express them as a whole squares. This square, x square minus x square, like. So it is not of this format. Because what we have here is linear. Okay. So this should be understood as the first format. This no way fitting in the second format, right? So here, who is the irrational part? Not let. Substitute. Some t square is equal to x plus 1. That's what the substitution, right? T square is equal to x plus 1. Now find the derivative of t with respect to x using implicit function. So that is t square derivative is 2t dt by dx into derivative of x is 1. And when we cross multiply and simplify, we got dx is equals to 2t dt. But that is not the only one we are going to substitute. We have only dx, we have got substitution, and then this x plus 1 we got substitution. What about this x minus 3x and all? That also should be expressed as t. Okay. Now what is the value of x from this? We got t square is equal to x plus 1. In place of x, we can get t square minus 1. Then what is the value of x minus 3? T square minus 1 minus 3. That is t square minus 4. Alright. Now shall I erase this side? Now we will replace all these things. That means we will name it as I. So our integral I is equals to integral. In place of x, what we have to substitute? T square minus 1. In place of dx, what we have to substitute? It is 2t dt divided by, in place of x minus 3, we have to substitute t square minus 4. Okay. Into, in place of root of x plus 1, what we have to substitute? It is t. Root of t square. Root of t square, that is t. Then that t and this t gets cancelled. We get integral t square minus 1 by t square minus 4 into dt. Now look at this. This is of what format? Is it possible to integrate this? Is this integration friendly? Direct substitution, sorry, direct formula substitution. What kind of fraction it is? Improper fraction. Heard this anywhere? So we should make it as proper. How we can make it as proper? We divide this. Divide this t square minus 1 divided by t square minus 4. Why I am calling it as improper? Because degree of the numerator and degree of the denominator is equal. We should divide them and we will make them like quotient plus remainder by divisor. That like format we can write. So when we divide, that is 1 times, it is t square minus 4. So here minus plus, these two will get cancelled and we got plus 3. And this format has become what? Quotient. Quotient is 1 plus remainder 3 divided by divisor. That is t square minus 4 into dt. Okay. Got it? Now you look at this. Do we have hope on this? You can integrate them, right? Peacefully. Integral of 1. Yes, t square minus what it is? Yes, but we should get the strike right. T square minus 4 plus 3 like in the numerator we can write, and then that we can split. Or else we can do one thing. Algebraic twins we have seen, right? We can put minus 4 plus 4. Then t square minus 4 we can combine, we'll get this, and then t square plus 3 like we'll, no, what we might get, t square minus 1, then plus 3 divided by the total, that's all. Okay, both ways we can do, not a problem. But if it is not possible, this is the only possibility. Okay, and then see, it is purely quadratic, you have got this idea. Suppose it is not pure, x terms, that t terms and all will be there, means how we can do? Only division is possible. Okay, so and then here integral dt plus integral 3 is a constant, we can keep it as I said, 1 by t square minus 2 square into dt. Integral dt is t plus 3 into, what is formula for this? 1 by a square minus x square. Log of 1 by 2a that means t plus 2 by t minus 2 plus c. And then what is our t? What we substituted? It is root of x plus 1, right? You have to substitute that over there. So we got root of x plus 1 plus 3 by 4 into log of root of x plus 1 plus 2 divided by root of x plus 1 minus 2 plus c. Oh yes, we did miss this 2, we missed, was it? So that should be multiplied in front, then that is correct. 3 2s are 6, and then we get 6 by 4. 6 by 4 means 3 by 2. Here 2 will be there. Okay, any doubts in there? Okay, good.